We're going to be talking about how to solve x squared plus bx plus c. Okay, this is a basic quadratic equation. Okay, for our warm-up, we want to remember how we factored. Remember, when you factor, you always have to find the GCF. Okay, when we factor these expressions, the GCF here would be 4r, and then if I factor out a 4r, you look to see what you'd have to multiply 4r by, or what you'd have to distribute to get what we started with. 4r times 2r would give me the 8r squared, okay, and then we'd have 4r times 3 gives me the 12r. Should be a pretty easy review from what we did in the previous lesson. So the main thing we're working on is factoring x squared plus bx plus c. Remember, this is a quadratic equation, quadratic function, because we have that squared term, okay? And this would be a trinomial. So to factor trinomials in the form x squared plus bx plus c, okay, we want to find two integers. Just remember, integers is the same thing as a number. So we're finding two numbers, m and p, with the sum of b and a product of c. Okay, then we're going to write x squared plus bx plus c as the quantity of x plus m times the quantity of x plus p. Probably sounds pretty confusing. Okay, you'll see it's not quite as confusing as this actually looks like. What it ends up being is you have this middle term b, so b is your middle term. C is your last term. You know your numbers, so we're going to be finding two different numbers, that's what they're saying. The numbers always have to add to equal b, and the numbers we find have to always multiply to equal c. So we add to the middle term, add to get the middle term, multiply to get the last term. And hopefully this should make sense from FOIL, that these two numbers, when we multiply them together, gave us our last term. Okay, and they got to add to give us our middle term. So what we're trying to do is factor these quadratic equations and expressions and get them in the form of two binomials being multiplied together. So if we look at our example, we have x squared plus 6x plus 8. So I need to find two factors of 8, because it needs to multiply to be 8, where the numbers add to 6 and multiply to get 8. And if you look, we factor it as x plus 2 times the quantity of x plus 4. And this works because 2 plus 4 is 6, and 2 times 4 is 8. And if you were to actually go through and FOIL out these two binomials, you would end up getting x squared plus 6x plus 8. So like we talked about in the last lesson, how distributing and factoring are opposite, FOILing and factoring are also going to be opposite or inverses of each other. Okay? And then this down here is just a little hint. When c is positive, its factors have the same signs. Okay, so they're either both positive or both negative based upon the sign of b. Okay, if b is positive, then everything's positive. If b is negative, then both factors are negative. Which hopefully makes sense that both of these would still give you that positive last term, because a positive times a positive is a positive, and a negative times a negative is also a positive. Okay, so looking at our first example, we want to factor x squared plus 9x plus 20. Okay, if we look, our middle term is 9, the last term is 20. 9 and 20. Since c is positive and b is positive, we know it's going to be two positive factors. That's what that hint was kind of just talking about. And we need these numbers to add to 9 and be a product of 20. And these numbers will always be factors of 20. Okay? So one way you can think about this is to make a table and do factors of 20 and then do sums of your factors. Okay? This is one way to do it. Another way to do it is I always write x plus, since I know both signs are positive. Okay, and then I just start trying numbers. So, okay, we could try like 1 and 20, because that's the first one. Well, 1 times 20 is 20, that's good. But 1 plus 20 is not 9, so that's wrong. And then you can keep trying other numbers. What they're trying to let you see, though, here, factors of 20, 4 and 5. 4 times 5 would give me the 20 I want, because we know these two numbers have to multiply together to be c, and they have to add together to be b. So we have positive 4 times positive 5. That gives me the positive 20 I want. So do they multiply to equal 20? Yes, they do. and do they add to equal 9? 4 plus 5 is 9. That works out too. So that means this is going to be my answer. The way you factor x squared plus 9x plus 20 is the quantity of x plus 4 times the quantity of x plus 5. And if you wanted to check this answer, you could actually FOIL this out. You would get x squared plus 5x plus 4x plus 20. And you get x squared plus 9x plus 20, which is what we started with, which is good. Okay? But when you're factoring, it's always going to be in this form, two binomials, and we know the two numbers have to add to be our middle term, which they did, and they have to multiply together to be our last term.